In this debugging session, I never actually executed any instructions. I was only looking at this disassembly window. So at this stage, I will just simply go to the debug menu and say stop debugging. I'm not going to run this program, just stop it. Okay, so that's something that you should know, that you can close or stop the program that's being debugged. I don't know where this console window is. I just close that as well. Let's resize this. And subtract instruction is quite similar to add instruction. Once again, it subtracts basically from destination. It subtracts the source and stores it back in the destination. So the mnemonic of the command is subtract. Once again, similar consideration as we had increment versus add, similar consideration regarding subtract and decrement. So decrement, of course, subtracting 1, and subtract allows us to subtract variable types, variable numbers. Comparison instruction typically used before we do any kind of conditional jumps. But this is, of course, the core building block of if-else structure. Okay, so for instance, if I want to compare registers, for example, I could compare registers like this. I can say CMP compare register, let's say AH and AL. If you recall, the structure of register EAX is such that register EAX is occupying 32 bits. It's a 32-bit size register. So this is bit 31 and this is bit 0. It's broken down into 2 halves, and you can refer to this portion of the register, which is 16-bit size. So this bit right here is bit number 15. Okay, so this portion of this register can be referred to as AX. So the entire 32 bits is named EAX, and this part, which is only 16-bit size, is named AX. And therefore, if I change EAX to AX, I'll be updating only this portion. This will remain intact. But also the AX part of it is broken down to 2 halves, and it's called AL, which stands for the low accumulator, and AH, which is the high part of the accumulator, AX. And so now this instruction compare compares 1 byte, so this is 8-bit and this is also 8-bit, so it compares 2 bytes. It basically compares these 2 values, okay, and then I can say if these 2 values are equal, as in this example, right, we can say that jump if equal. So if the outcome of this comparison is such that the registers are equal, I can jump to some kind of a label. Okay, so this is a strange name for a label, and this is the syntax, but I'll just place it right here. So you need to specify the name of the label, and I'm just using this, any any name label right here. So I can jump over in. If I have another, for instance, if I had another set of instructions right in the middle right here, so if I've written more instructions right here, of course, if AH and AL are equal, jump if equal will transfer control from here to the next instruction, which will be under this label, and it will skip all of this. So this is like an if condition being false. Okay, so that's the implementation of if else. If you want to write some pseudocode right here, we can say if, right, so we can say if AH equals AL, then what we do is we basically jump. This doesn't require a comment, or we can say then jump, right, something like that. And if this condition is true, but if this condition is false, we would execute instructions that are found right here. So this is the building block of if-else control structures in C programming language, compare instruction. There are also unconditional jump, which is just JMP. We will discuss flow control in the future, so right now I'm not going to spend too much time doing this, just showing you what this looks and feels like in assembler to implement like an if condition statement. Conditional jumps all starts with the J, and then some kind of mnemonic is also attached to it. For example, JE stands for jump if equal. JNE would stand for jump if not equal. So these are examples of some of the jump instructions. We will have a dedicated section to flow control and all sorts of ways to jump from one place to another in the program, including conditional jumps and unconditional jumps in our future sessions. So right now it's just examples of some of the mnemonics to expect when you write code implementing those if statements. And so these are conditional jump instructions that test the values of different CPU flags. Once again, this will be discussed in more detail in the future. There's a loop instruction, which is equivalent to these examples right here. So basically, the instruction looks like this. For instance, we can load. It requires register EAX to operate. Move ECX. Move ECX, for instance, 3. Okay, so this becomes loop counter. Right, so this is our loop counter. And then we can do some things in the loop. We can now here do things inside a loop, and just to give you an example, we could be once again incrementing register EAX, and at the end of it we can say loop, and loop requires a label to jump, and I will add this label as top of the loop. Again, those are just silly names of labels. I'm just using something right now, and we need to specify this. I'll save this program, and I'll try running it, and I'll move this. In fact, I'm sorry, this is like should say initialize loop counter, right? And so this is above the loop, but this is like the top of the loop. And now we can try this running it. Let's just set breakpoint right here. We have no other choice but to use a debugging environment and look at the program execution and steps, because we don't interact with the user right now. So I'll just build this and debug, start debugging, or pressing F5. Okay, so once again, I'll close the disassembly window now. So it's our program. So we're about to load ECX counter register with value 3. So step over F10. You can see that it's now set to 3. We increment EAX. EAX is currently equal 5 right here, right? So this entire register, 32-bit register, is loaded with value 5. So we're about to increment it. Press F10. Right here you can see it becomes 6. Then we make a loop. So what loop does, it jumps back to this label, which basically is the address of this instruction increment EAX. But it also decrements the counter. So the counter became 2. And we're jumping now here to increment EAX again. So press F10 to step over. You can see that EAX again got incremented. The loop instruction will again decrement ECX and jump to the specified label. So pressing F10 again, so it jumps to the label, but really this label is the address of the instruction that is following here, and this is where we end up. So now ECX became 1, and we're about to increment EX one more time, so EX becomes 8, and we say loop again, and ECX became 0, and under such condition the loop no longer makes a jump. So this is like a while loop implementation, or do while. We can say that basically this is like do this, like we would structure it in C, while register ECX is greater than 0. So this is how it works, okay? And this, of course, would be the body of the loop, between the top of the loop that kind of corresponds to the do keyword in C, and the bottom part of we can even add like opening braces that would typically be accommodating such code in C, right? So and this is our condition. And by the way, just to be more clear about this loop, we should also add decrement of register ECX. Decrement happens before this value is compared to 0. So as long as it's not 0, perhaps we should even say it this way, right? If decrement ECX happens and ECX is not equal to 0, then we go back to the top of the loop, and we continue to execute the loop. So this is your example of a loop command in assembler. So you can just kind of look at some of these examples right here.